So in order to sketch the graph, look at the notes. We need to follow the steps. First, we need to find the domain of the graph, right? Second, we need to find the x-intercepts and y-intercepts. How can we find the x-intercepts? Yes. How can we find the y-intercepts? Yes, set x is equal to 0, right? And here, let me go back to the example. Here, the domain is any value of x, which the function is defined. Therefore, we cannot take the x value, which is equal to 1 or minus 1. Therefore, this is the domain. The y-intercept, we set x is equal to 0. We find that a0, 0 is the y-intercept. Similar story, we solve this equation, find the solution, and these are the x-intercepts. Okay. Then we check the symmetry. If f of negative x is equal to fx, then this is an even function. Therefore, it is symmetric about the y-axis. If it is odd, then it is symmetric about the origin. Okay. If it is neither even nor odd, then there's nothing special. Okay. We find the asymptotes. There are two types of asymptotes. First one is horizontal asymptote, right? And the second one is vertical asymptote. Horizontal asymptotes are the limit when x approaches positive infinity or negative infinity, right? In this example, they are, so we find that limit when x approaches infinity, it will be 2. Therefore, the horizontal asymptote is the line y is equal to 2. That is the first one, right? Okay. And when x approaches negative infinity, what is the horizontal asymptote? Also, y equal to 2 is the second one, right? Which is identical to the previous one. So we have only one horizontal asymptote. Okay, now we need to find the vertical asymptote. It means we need to find the limit from the left and the right of the undefined position. In this case, we need to find the limit when x approaches 1 from the right of the function f of x, or specifically in our case, it is x squared to x squared divided by x squared minus 1, right? That is the first one. And the second one is the limit from x approaches 1 from the left of 2x squared over x squared minus 1. That is the position when x is equal to 1, right? So let us do it first. Here, the limit when x approaches 1 from the right-hand side. When we substitute 1 here, it is undefined, right? So how can we do it? Do you remember?
Would you set the numerator equal to 1 or?
If we set the numerator equal to, when we substitute the value at 1, it would be 2 over 0, right? It has the forms 2 over 0. Very small numbers, yes, in the denominator. But in, yeah. And here in the numerator, it will be close to 2, right? So which rules should we use here that we have studied in the previous section? It has a forms 2 over 0, right? Remember. We cannot do it in the L'Hopital rule. But any idea?
You substitute a number that's bigger than 1, and it will be positive infinity. And then for the limit as x approaches 1 from the left side, if you substitute a number just smaller than 1, you will have negative infinity.
Yeah, that is also a good explanation, right? Remy, you were right. See that when x comes close to 1, it becomes very small, but it's still positive. So this one will goes to infinity. We're good to do it. And Daniel explained it very clear. Okay, when x come close to -1, but from the right, from the left, it's still okay because when we square it, right? It is a very small number. It is very close to 1, but smaller than 1, right? And it is negative, so it will be negative infinity. Very good, Daniel. Thank you, and Remy. So another number is the limit of the function divided by x squared minus 1 when x approaches -1 from the right, right? And limit when x approaches -1 from the left. Negative from the right, -1 from the right. It means it is here, right? Somewhere here. The absolute value of that is smaller than 1. So when we square, it's still smaller than 1, right? Smaller than 1 minus 1 will be a smaller, very small numbers, but negative, right? In the numerator, it is a positive number. Then, therefore, it approaches what? Is it positive or negative?
Again, you have to say 15 per game.
Negative infinity, right? Here, if it approaches negative 1 from the left-hand side, it will be somewhere here. And the distance of that to 1, the difference here, the denominator will be a number which is bigger than 1, and subtract 1. It becomes a very small number, but positive. 2 and multiply with a negative 1 square give us 2. 2 divided by a positive small number, which will be positive infinity. So, very good. Let us continue. In the notes, which step should we go next? The asymptotes right now. The interval of increasing and decreasing. It is intervals of increase and decrease. Okay. So what should we do here? What should we do? Yes, we find the first derivative of the function f of x, which is the derivative of 2x squared divided by x squared minus 1 prime here. And this is a quotient rule. So what do we have? And very good. Quotient rule, right? And the denominator square. Thank you, Carson. Good job. So let us simplify it. So here, 4x, okay? The numerator and the denominator. In the numerator, what is the common term?
2x.
Yeah, or here we see that there is another 2 here, so we can factor 4x out at the same time, right? 2x is fine, but we can do even more. Who was that on Zoom?
Carrington.
Thank you, Carrington. And if we factor 4x out, what do we have inside? Very good. Thank you, Faith. Okay. Do you all see it? Good job. So now x squared and then minus x squared, they cancel each other. And here is a negative number 1. So this terms becomes negative 4x divided by x squared minus 1 squared, right? Good job. Remember, by making a table will help us a lot. So let us do it that way. A table representing the f prime function. So let us consider the value of of x on the left here. Right. Okay. Look at this. The denominator x is not 1 or minus 1. Means that the denominator will always be non-zero. That is in the domain, right? Let us write the negative 1 and 1. When we set the f prime to be 0, what is the solution of f prime is equal to 0?
Zero.
It is 0, right? Okay. Now we see that the negative 4 is always be a negative constant, right? Let us write it negative here. All over the domain. Okay. And this, the domain of this is undefined. We exclude the value of negative 1 and 1. So let us write it this way to imply that, okay, the domain does not include this point. Okay. The double bar, okay? They're not defined there. So at 0, the function x here, it will be, what is it? Yeah, 0. And from the left of 0, what is the value of the function x here? Perfect. Negative, negative here, positive, positive here, right? How about the denominator here? It is undefined at these two, right? But it is anything here but then square. So is it positive or negative? It's always positive, right? Something square is always positive. Very good. So at 0, the f prime is 0. So let us put it this way. Okay. Finally, f prime is the product of these guys, negative 4 multiplied x and then divided by the denominator here, which will be, what is it in this domain here? Positive. Very good. Right. And here from negative 1 to 0, is it positive or negative? Yes, positive. And negative times positive divided by positive, it will be negative. And here, Okay, very good. We know the first derivative of this, and the part of positive here, it means that it is increasing. Very good. And here it is also increasing, right? Here it is negative, therefore it is decreasing and decreasing. Okay, very good. What else? In the next steps, let me see. So we know the intervals of increasing and decreasing. Here, can we find the maximum and minimum? Wait, hold on a second. Here, let us put in the limit here. At when x approaches negative infinity and positive infinity, they are all equal to 2, right? That is the value of function f. So we care about f later. Or let us put it this way. If we also study the value of f of x, let us write it this way. If we also study f of x here, at negative and f of x is undefined here. Okay. So when x approaches negative infinity, we know that it is 2, right? F of x. And the same story when x approaches infinity, it is also 2 from the asymptotes. And when x approaches -1 from the left, we see that here it is positive infinity, right? It is positive infinity. And from the right side of -1, it is negative infinity, right? And a similar story at 1, here it is negative infinity. And from the right side of 1, it is positive infinity. Okay. That is the value of f of x. Then let us continue. The local maximum and local minimum. So can we find any local max and local min? From f prime here, we don't see any, right? Local max, if it is increasing, then decreasing. But there's not such a point. And similarly, there's no local mean. So here, let us write it. In this case, there's no local max and no local mean. In the next step, we need to study concavity and points of inflection. Okay? Concavity and points of inflection. Okay? So,
I have a question.
sure.
Why isn't the point at 0 considered a maximum since like it increases towards 0 and then
Yeah. Oh, we missed one point. Thank you very much. We missed here. This is a maximum, right? Very good job. Who was that? I'm sorry.
Carrington?
Harrington, thank you so much. I've missed here. It is a maximum, right? It is increasing then decreasing in this interval. Very good. It is not. Because here you see when there's some point that it has larger value, it goes to infinity here, right? Yeah. Thank you, Carrington and Rami. It is an amazing catch. Yeah, sometimes we forget and didn't check it carefully. Very good. So, concavity, we need to find the second derivative, right? So, f prime prime of x, it will be the derivative of the f prime. In this case, we found that f prime was negative 4x divided by x squared minus 1 and then square. Okay. Again, we use quotient rule. Before doing that, we see that the constant negative 4, we can take it out of the derivative, right? It makes our computation easier. So we don't have to deal with big numbers anymore. Okay. Then what is it now? Yes, quotient rule give us let us write it this way, right? And then square give us to the fourth. Very good. Here, remember, just be careful. This is negative 4 multiplied with the whole numerator here. So let us write it carefully. Okay. Very good. And distribute it to here, give us 1 multiplied with this square, right? Let us write it this way. We do not expand it. And here, the derivative of this guy, it is u squared, where u is x squared minus 1, right? What is it now? What is derivative of x squared minus 1 and then square? Very good. Times the derivative of x squared minus 1, which is 2x here. Perfect. Very good. Do you all see it? So, very good, Carson. The reason we did not expand this perfect square, because later we can group it with x squared minus 1 here, so that our computation is easier. Negative 4. Then here, if we factor the like term out, which is x squared minus 1, So what do we have inside the parentheses here? Here, x squared minus 1 square. We take one of them out here, then it is left that x squared minus 1, right? From the first terms. From the second terms here, we have x times 2 and x times 2, right? Which is, and remember there's a negative sign. What is it?
Four x squared.
Very good. 4x squared. Perfect. Who was that on Zoom? Maurice?
Carrington.
Carrington. Thank you, Carrington. Oh, we have that. Very good. Now, here, look at this. It is x squared minus 4x squared. Give us, what is it? Very good. Negative 3x squared minus 1. Good job. Here, again, in the numerator, we have x squared minus 1. In the denominator, we have x squared minus 1 and raised to the power of 4. Right? Can we simplify it? Good job. Which will be? Yes. And the negative 4 here, can we multiply the negative sign to the parentheses here? To make it positive, easier, right? Then let us write it 4 times 3x squared plus 1 divided by x squared minus 1 and then cube. Okay? Are we good? But it is cube here. Let us write it. For 3x squared plus 1 here, and x squared minus 1, it will be x squared minus 1 squared multiply with x squared minus 1. Do you agree? To the power of 3, we separate it into 2 terms. Okay? And again, x squared minus 1, we can write it x minus 1 and x plus 1. Okay? You will see why we need to do it. It makes our life easier. Let us see. Now, again, we need to make a table, right? Of f prime prime. We do a similar things. We consider the value of x here from negative infinity to negative positive infinity. And we know that this function is not defined at -1 and 1, right? When we solve this equation, we set it to be 0. Can we find any solution? This one is always different from 1. It is not 0. And when we solve this, it is equivalent to the numerator equal to 0, right? But we know, look at this. We know that, let me bring it down here. We know that the domain does not include plus and minus 1, so it is equivalent to solving 4 times 3x squared plus 1 equal to 0, right? And we see that x squared is always larger or equal to 0. Therefore, 3 times x squared is always larger or equal to 0. A number bigger than 0, if we add 1 here, then it will never be 0, right? Or in other words, there's no solution. For this equation, okay? Do you all see it? Right? This is the reason. So we cannot find any solution of this second derivative. Okay, we're good. It means we need to care these values only. Special value, right? So let us consider here 3x squared plus 1. 3x squared plus 1. It is the numerator. And here the number 4. And in the denominator, we have x squared minus 1 and then square. And x minus 1 in the denominator. And x plus 1 in the denominator. And finally, the second derivative function. Okay? These are all things we need to care. Okay? Now, we know that this guy is always positive. More precisely, it is always larger than 1, right? Here, the number 4 is always positive again. Okay. Here, something different from 1 and then square, it is always positive. Very good. Here, x minus 1, what is the solution of this guy? Right here, right? The solution of that is here. X minus 1, let us call it here. How about the solution of x plus 1 here? Yes, solution is negative 1. And okay, in general, the function f prime prime, so the domain here does not include this value, or we can simply say, okay, the domain does not include this value. We can also say that it is undefined from this value, okay? Then, for the function x minus 1, the solution is 1. Therefore, what is the value of this in the left-hand side of 1? Yes, negative, and then positive here, right? Similarly, here, of x plus 1, Yes, negative and positive, positive here, right? So then the f prime prime will be the product of 3x squared plus 1 multiplied 4 and then divided by this guy. Finally, from negative infinity to negative 1, is it? Very good. And here, negative, and here, very good. And the second derivative, if it is positive, then it is concave up or down? Up, yes. And here will be concave down. Here is positive, then concave up. Okay, very good. So we have done it very slowly and clearly. We know all the information, right? Then we can sketch the graph. Okay, let us do it together. Now, suppose this is the coordinate. This is y, this is x, and at the point plus and minus -1, it is special. It is undefined. So if it is undefined, let us draw it by dashed line. Okay. Then we draw the vertical and horizontal asymptotes. These are the vertical asymptotes, right? And the horizontal asymptotes is at 2, right? Two is right here. So this is the horizontal asymptotes. So let us use the dashed line for the asymptotes. Okay. And we know that if x is at negative infinity, what is it? Is it positive or it is 2, right? It means that the graph at negative infinity, it is very close to 2. It is somewhere here. From the left-hand side of -1, it is positive, right? It should be somewhere here. From the right-hand side of -1, it should be negative infinity. Let us. From the left-hand side of 1, it is negative infinity. From the right-hand side of 1, it is positive infinity. And from positive infinity, it is approaches 2, right? So we know that here, oh, one more thing. The maximum, let us pull it up a little bit. The maximum here value is at 0, right? F of 0, what is it? What is f of 0? Evaluate the value of the function. 0,
Yeah.
yes, here. 0, very good. So we know all the key things here, right? It is increasing in the interval from negative infinity to -1. It should be like this. Right. And here from negative infinity, it is increasing up to 0 and then decreasing. And from here, it is decreasing from positive infinity to this, right? And it is symmetry. So we flip over about the y-axis, the same. So this is the graph of the function. So is it clear? This method we can apply for any graph. So let me quickly review the odd and even equation. Okay. So we are done with this example. Okay. And tomorrow I will send you a note of another examples. You will redo it at home. Okay. And tomorrow we will start with a new section. Are we good? But for now, we haven't done yet, please. Because, so check if the function f of x is sine of x, if it is even or odd. In order to do so, what do we need to do? We need to evaluate the value of the function at negative x, right? So from this definition, what is it now? Yes. And from trig functions properties, we know that this sine of negative x is equal to sine of x. Or we can write it. We know that sine of x is fx, right? And the negative sign here, it means that it is negative f of x. It's satisfying this. Therefore, it should be is it odd or even? Yes, it is odd. Similarly, odd, therefore it is symmetric about the origin, right? Okay. The similar question, if we check f of x is cosine of x, we need to evaluate f of negative x. In this case, it will be cosine of negative x, right? And cosine from trig functions properties, we know that it is also the same as cosine of x. Then again, cosine of x, which is exactly negative f of x, it is f of x. Therefore, it is even. If it is even, then symmetric about the y-axis, right? Okay, I'll see you tomorrow. You all have a good one.